Welcome. In this video we're going to cover the most basic features of UML class diagrams. Let's do so in the context of a hypothetical library system, which we're going to say is going to have to deal with books and copies. So we're going to have a class book in our system and a class copy. Just as with object-oriented programming languages you might be familiar with, classes are given names in the singular and the names are capitalized, just as with every other UML classifier. So a classifier classifies instances. The instances of classes are objects. Classes in UML are represented using rectangles. I'll draw them quite big because I'm going to want to add some compartments to them in a little while. So now we've got a class diagram that shows two classes. They have something to do with one another. They're associated, which is to say there's some concept of a link between instances of book and instances of copy. It makes sense to ask, is this particular instance of the book class, this particular object, book, linked via this association to this other particular object of class copy? The answer will be yes, for example, if the book object is representing the book War and Peace and the copy object is representing copy number 17 of War and Peace in the library. So we can name the association accordingly. Is a copy of... now we hit something interesting here. Naturally we read top to bottom and left to right, at least when we're reading in English, but in this case we want that name to be read from right to left. It's a copy which is a copy of a book. We can ensure that using a nice little piece of notation which is just a filled in triangle pointing in the direction you want somebody to read the association name. You wouldn't normally bother if you had succeeded in naming the association so that they would be read in the natural sense, top to bottom and left to right, but sometimes it's useful to be able to do this. There's a load of other kinds of annotations we can put on associations. For now, let's just cover the most common one, which is multiplicity. So often we want to say, given an object of one of these classes, how many objects of the other class might it be linked to? So let's think about this in this case. Supposing we take a copy object, perhaps it's copy number 17 of War and Peace. How many book objects might it be linked to? Well, that's easy, just one. Okay, the copy is going to be a copy of one particular book. We're assuming for the moment that the books are the only thing in the library that a copy might be a copy of. So we'll represent that by putting multiplicity 1 on the book end of the association. Make sure you internalise which end of the association the multiplicity goes on. So given a copy, one book. What about given a book, how many copies? Well, we've already admitted that there might be 17 copies of a book. Let's suppose that there's no limit on how many copies of a given book we might have. We do have a bit of a question to say, are we going to permit there to be book objects in our system of which there are 0 copies? Now that's something you might have to think about in your particular case. Let's suppose we've determined that we do want to allow that. We can represent that, which is to say there's really no limitation at all, it could be 0 or any positive number, using the notation in UML star. Okay. Now, synonymous with that, and what actually people will often write in UML diagrams, is something which we might write as 0 dot dot star. That dot dot, notice by the way it's always 2 dots in UML, not 3. I'm not sure what the history of that is, but it is so. You can put basically anything there and anything at the star end. It could be 6 dot dot 16 if for some reason you wanted to say there must be at least 6 copies but no more than 16 in the system. Okay. So that's our association. Now let's think about what other information we want to put in the diagram to tell us more about the class. The two main categories of information we may want are what is the data associated with each object and what messages does each object understand. In other words, what are the attributes and what are the operations of the class. And by convention, the attribute compartment comes immediately below the title, and the operations compartment comes immediately below that. It's possible to record further information in UML class diagrams, but this is what you'll usually want. So let's suppose that the most important data associated with a book is its title. We represent that by giving the name of the attribute and colon its type. So we can say title has type string. Now, what messages does a book object understand? Let's suppose that after some discussion we find out that it's important that a book object understands the copies on shelf message, which will return an integer, which means this book object has carried out some kind of calculation, and it can give you the integer that says how many copies of this book are on the shelf right now. We can represent that by saying we've got a copies on shelf message, which takes no arguments, let's say, and I've run out of space, oops. It's going to return an integer. Okay. And just to demonstrate that we can have objects as arguments as well, let's suppose that we also have to understand a borrow message, which is going to take a copy object as argument. Let's say that this is the message that the book object is going to be sent when a particular copy is borrowed, so that it can update its records and understand that that copy is no longer available, whatever it might be. Okay. We're nearly done. I just want you to notice one thing that we don't have in this diagram. We do not have an attribute in the book class which is anything like a collection of copy objects to represent the collection of objects that are linked to it by this association. The reason we don't do that is because that information is already in the diagram by means of the association and the presence of the class copy. And as always in software engineering, we try not to record the same information in two different ways, at least not on the same diagram. Partly just because it's wasted effort, and partly because as soon as you do that, you have the potential of the two representations of the same information getting out of sync, and then that causes confusion. As a general rule, the types of attributes in a class diagram will be either basic types out of your language, like string, or types that come from somewhere outside this class diagram. You wouldn't expect to have an attribute in a class diagram whose type is a class which is another class in the same class diagram, if you see what I mean. That's a good place to stop.